The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, well, eventually here we're going to go on to section 14.3, which wraps up the information for this first test. Tomorrow we will be reviewing the material for the test, and then on Wednesday there will be no class Zoom meeting. You'll just take your test, and you can take it any time up until Wednesday night at 11:59. It needs to be finished. Anyway, I didn't get any requests from people for through email or for questions from the weekend's assignment. Do any of you have any questions from section 14.2 before we go on?
I don't.
Okay. Anybody? All right. Well, we'll go ahead and proceed. So I'm actually going to do just a quick review of section 14.2, which was arithmetic sequences. And we had this formula, a sub n equals a sub 1 plus the quantity n minus 1 times d, where n referred to the subscript of a specific term in the sequence, and d was known as the common difference. If we took any term in the sequence and subtracted the previous term, we would get the common difference. All right, today we're going to look at geometric sequences, and they are of the form a sub n equals a sub 1 times r to the n minus 1 power. So we're multiplying here, a sub 1, the first term, times r. R is going to be known as the common ratio, okay? Let's see. Anyway, r is the common ratio. And so whereas with a arithmetic sequence or an arithmetic sequence, you take a sub 1 plus the common difference, you get a sub 2 plus the common difference, you get a sub 3. With a geometric sequence, you take a sub 1 times the common ratio to get the next term, and that term times the common ratio to get the next term. So let's say, for instance, we had the geometric sequence 1, 2, 4, 8, 16, 32, 64, etc. Well, the first term is a sub 1, which is 1. The second term is a sub 2, which is 2. The third term, a sub 3, is 4. The fourth term, a sub 4, is 8. So 1 times what is 2? Or 2 times what is 4? Or 4 times what is 8? 2. So the common ratio for this particular sequence is 2. Now, how do you find that just looking at the terms? You go backwards. If you take a term in the sequence divided by the previous term, a term in the sequence divided by the previous term, you get the common ratio. All right, let's take a look at some examples of problems. And let's see here. This says, write the first 5 terms of each geometric sequence with the given properties, and then find the specified term. Okay, so we want to come up with a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. We're going to use the formula a sub n equals a sub 1 times r raised to the n minus 1 power. So that n minus 1 is now the exponent on r. Okay, it says the first term is 3. The common ratio is 2, and we are to find the 9th term. So we're supposed to find a sub 9. All right, Just like with arithmetic sequences, we could use the common ratio as opposed to the common difference. So if we take a sub 1, which is 3, times r, we get a sub 2. Well, 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. And we could continue that to a sub 6, a sub 7, a sub 8, a sub 9. But we're not going to do that, because what if I asked you to find a sub 246? You wouldn't want to sit there and crank that all out. So we're going to use a process similar to what we did in the previous section, and that is this. Again, using this formula, let's see here. Oh, wait, my bad. We haven't gotten to the more complicated stuff yet. This is just a matter of plugging things in. A sub 9 is a sub 1, which is 3, times r, which is 2, to the n minus 1 power, which is 9 minus 1. Okay, so here we already have the first term, we already have the common ratio, so we can just plug the numbers in. So a sub 9 is 3 times 2 to the 8th power. Recall order of operations, we would do the exponent before the regular multiplication. So we take 2 to the 8th power, and that times 3, not 3 times 2 is 6, and 6 to the 8th power. So let's see, 2 to the 8th power, 2 to the 8th power is 256. And that times 3 is 768. So we've got the first 5 terms and the 9th term of the sequence. Any questions on that example? All righty, let's take a look at another example. It's again says to write the first 5 terms, a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. And it says the first term is 8. The common ratio is 1/2. Find the 10th term. Okay, so again, we're going to use the common ratio, and we're going to use the formula a sub n equals a sub 1 times r to the n minus 1 power, because this is a geometric sequence. 8 times 1/2 is 4, times 1/2 is 2, times 1/2 is 1, times 1/2 is 1/2. Okay, so that's how we could get the first 5 terms. A sub 10 is a sub 1 times 1/2 to the 10 minus 1 power, which is 8 times 1/2 to the 9th power. Let's see here, 1/2 raised to the 9th power. I'm getting a decimal number. Now, and that might be rounded off. I want to get a fraction or mixed number answer. Again, I'm not going to put a mixed number into WebAssign, but so how can I do that without getting a decimal? Well, we could expand this and say this is 8 times 1 to the 9th power over 2 to the 9th power. 1 to the 9th power is 1. 2 to the, and here, 2 to the 9th power is 512. Okay, so now I've got 8 over 512. Well, since 2 to the 9th power is 2 times 2 times 2 times 2, etc., 8 is going to be a factor of that. So if I divide the top by 8, I get 1. If I take 512 divided by 8, I get 64. So final answer, a sub 10 is 1 over 64. Any questions on how I did that? All right. This says, find the specified term of the geometric sequence with the following properties. The first 3 terms are 2, 6, 18. Find the 7th term. All right. So a sub 1, a sub 2, and a sub 3 are 2, 6, and 18. We are to find the seventh term. Okay, now they told us the first term, but they didn't tell us the common ratio. We're going to use the geometric sequence formula. A sub n equals a sub 1 times r raised to the n minus 1 power. I need to find r. Recall a few minutes ago I said the way to find r is to take any term in the geometric sequence divided by the previous term. The one exception is we couldn't take a sub 1 and divide it by the previous term because there is no previous term. But all right, so if I take 6 divided by 2, I get 3. Or if I take 18 divided by 6, I get 3. So the common ratio is 3. Any questions about how I found that? All right, so now that I know the common ratio and the first term, I can just plug that all into this formula. A sub 7 equals 2 times 3 to the 7 minus 1 power, which is 2 times 3 to the 6th power, which is 2 times, let's see here, 3 to the 6th power is 729. That times 2 is 1,458. Okay. Any questions about that? Okay, let's see here. This says, write the first 5 terms of a geometric sequence with the following properties. Okay. It says the first term is 2. It says r is greater than 0. And it says the third term is 18. So we have to find a sub 2, a sub 4, and a sub 5. Now, they told us that the common ratio is positive, which also means it's not negative. Let's see how that comes into play. All right, we're going to use the formula. A sub n equals a sub 1 times r to the n minus 1 power. We know a sub 1. We don't know r yet. But we could do this. And this is kind of what I was thinking we were getting into earlier that we did on Friday. A sub 3 equals a sub 1, which is 2, times r. We don't know what r is, but to the 3 minus 1 power, which is 2r squared. Okay? Any questions how I got that? We also know that a sub 3 equals 18. That's a given. So now a sub 3 equals this, and a sub 3 equals that. So from that, we get the following equation. 2r squared equals 18. Okay. I'm going to divide both sides by 2, and I get r squared equals 9. Now, we haven't gotten into full-blown square roots and cube roots and all that, and eventually we'll get to chapter 9 and we'll go into that extensively, but we're just going to get a little taste of it here. If r squared equals 9, what could r be? Well, 3 squared equals 9, but negative 3, the quantity squared, also equals 9. So what happens here is we get r equals, I'm going to say plus or minus 3, okay? Because if I take the square root of r squared, I get the square root of 9, but in fact, I get plus or minus the square root of 9. And what do I mean by that? I mean that r could equal negative 3 and r could equal positive 3, because both of those numbers, if you square them, you get 9. But here's where this comes into play. It says r has to be greater than 0. So in this case, we're going to get rid of the negative, and we'll just take r equals 3. So 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. 54 times 3 is 162. Let's see here. If we had used r equals -3, we still would have gotten 18 for r3, but r sub 2 would have been -6. So that's why they had to tell us whether r was positive or negative. Any questions about that? Okay, let's take a look at another one. Let's see. Write the first 5 terms of the geometric sequence with the following properties. The first term is 3, and the fourth term is 24. So r sub 1 is 3. R sub 2 we don't know. R sub 3 we don't know. R sub 4 is 24. And again, we're supposed to find the first 5 terms. Now, they didn't say anything about r being positive or negative. Let's see why. Okay. Again, geometric sequence. I'm going to use the formula a sub n equals a sub 1 times r to the n minus 1 power. I know a sub 1 is 3, but I don't know what r is yet. However, r sub 4 equals a sub 4 equals a sub 1 times r to the 4 minus 1 power. So a sub 4 equals 3, r to the 3rd power. 4 minus 1 is 3. Okay. But we also know that a sub 4 equals 24. So a sub 4 equals that, and it equals that. So here's our equation. 3r cubed equals 24. All right. Now, to solve for r, first of all, we'll divide both sides by 3, and we get r cubed equals 8. So now we want to take the cube root of r cubed, which is r, and the cube root of 8. Now, the cube root of 8 equals some number such that that number times itself is 8. Well, let's see. How about 1? 1 times 1 times 1. That's not 8. That's just 1. 2 times 2 times 2. What's 2 times 2? 4 times 2 is 8. So the cube root of 8 is 2 because 2 cubed is 8. So from that, we get r equals 2. Any questions about what I just did there? Okay. So 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48. And there we go. Now, why in this previous one, when I took the square root, I got 2 solutions, plus or minus. That's because -3 squared is 9, +3 squared is 9. But here, I only got a positive root. Well, -2 cubed would be -8. So it wouldn't be plus or minus 2. It'd just be +2 in this particular case. All right. We looked at some arithmetic means, some numbers we placed in between some given numbers. Now we're going to look at some geometric means. It says, find the geometric means to be inserted in each geometric sequence. This first one says, insert 3 positive geometric means between 2 and 162. So that means that a sub 1 is 2. Then we're going to insert 3 geometric means before we get to a sub 5, which is 162. So they told us the first term and the last term, and that there were 3 terms in the middle because it said find, or it said insert 3 geometric means. In fact, it says insert 3 positive geometric means. It did say that. So that's the same thing as saying r is greater than 0. Okay. Let's see here. We're going to use a sub n equals a sub 1 times r to the n minus 1 power. This is the second formula you could have on card while you're taking the test on Wednesday. The first one is that arithmetic sequence formula. A sub n equals a sub 1 plus n minus 1 times d. So you can have those two formulas on a card. If you were taking a test in class, they would appear at the top of the test. Anyway, okay. Back to this. So let's see. We know that a sub 5 is a sub 1 times r to the 5 minus 1 power. So a sub 5 is 2r to the 4th. We also know that a sub 5 is 162. So a sub 5 equals that, and it equals that. So our equation becomes that. Dividing both sides by 2, we get r to the 4th power equals 81. Well, if we take the 4th root of 81, if we take the 4th root of r to the 4th, we get r. The 4th root of 81, let's see, what times itself is 81? 1 times 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8, times 2 is 16. 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, so the 4th root of 81 is 3 because 3 to the 4th power is 81. Now, do I get a plus or a minus? Well, initially I would, except that recall the directions said insert 3 positive geometric means. So I would just get a positive 3. Okay, so back over here, 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. 54 times 3 is 162. So there's our 5 geometric or 3 geometric means in the middle of those terms. These days I'll learn how to talk. All right. Let's see here. What about this one? It says insert 3 geometric means, and then it says 2 positive and 1 negative between negative 64 and negative 1024. So a sub 1 is negative 64. Then we've got a sub 2, a sub 3, and a sub 4. There's our 3 geometric means. A sub 5 is also negative 1024. It tells us that of these means, 2 are going to be positive and 1's going to be negative. We'll come back to that in a minute here. So a sub n is a sub 1 times r to the n minus 1 power. A sub 5 is a sub 1, which is negative 64, times r to the 5 minus 1 power. A sub 5 equals negative 64 r to the 4th, but a sub 5 also equals negative 1024. So this equals that. Negative 64 r to the 4th equals negative 1024. To solve for r to the 4th, we're going to divide both sides by negative 64. So r to the 4th equals, well, let's see here. Negative divided by negative would be positive, and 1024 divided by 64 is 16. So I get positive 16 because, again, the negative divided by negative would make it a positive number. Okay, so we want the 4th root of r to the 4th. Since we're taking an even root, we're going to initially get positive or negative numbers, because the 4th root of 16 could be 2, because 2 times 2 times 2 times 2 is 16. But it could also be negative 2, because negative 2 times negative 2 times negative 2 times negative 2 would be positive 16. So r could be plus or minus 2. So positive 2 or negative 2. However, let's think this through. They said we're going to have, let's see, what did they say? 2 positive and 1 negative geometric means. Well, if I let r be a positive 2, what would I get? Negative 64 times 2 would be negative 128 times 2 would be negative 256 times 2 would be negative 512 times 2 would be, but that doesn't work because then they're all negative and I need 2 positives and 1 negative. What if I use r as negative 2? Then what happens? Hang on here. If r is negative 2, negative 64 times negative 2 is positive 128. Negative times negative is positive. 128 times negative 2 is negative 256. Negative 256 times negative 2 is positive 512. Positive 512 times negative 2 is negative 1024. And what do I have? 2 positive means and 1 negative means. So instead of them saying r is less than 0, they had us do it by figuring out which one would give us what they asked for, 2 positive and 1 negative geometric mean. Okay, let's take a look at this problem. Find a geometric mean to be inserted in each geometric sequence. It says find the geometric mean, so there's one of them, between 2 and 128. So a sub 1 is 2. We're going to have 1 geometric mean, and a sub 3 is 128. Okay, so we're going to find what a sub 2 is, the geometric mean. A sub n is a sub 1 times r to the n minus 1 power. We know that a sub 3 would be 2 times r to the 3 minus 1 power. So a sub 3 is 2r squared, but a sub 3 is also 128. So 2r squared equals 128. That's going to be our equation. Divide both sides by 2. R squared equals 64. Take the square root of both sides. Oops. So we get r equals plus or minus 8. So r could be negative 8 and r could be 8. Now, they don't tell us any more information. They don't say r is positive or r is negative, or there's going to be 1 negative mean or 2 positives or whatever. So in fact, we've got 2 possibilities. If r is positive 8, this would be 16. 2 times 8 is 16. 16 times 8 is 128. If r is negative 8, this could be negative 16. 2 times negative 8 is negative 16. Negative 16 times negative 8 would be positive 128. So a sub 2 could equal 16 or negative 16. 2 possibilities because they didn't narrow it down for us. All right. Well, that's all I've got. That wraps up the information that's going to be on the test. If you want more examples, I'll do that now. Otherwise, this is pretty much what's in this section. Does anybody want any more examples of these?
Yeah.
Yes? Sorry, was that a yes?
Oh, yeah.
Do you have any particular ones, the ones where you had to take the roots of each side, or finding the first 5 terms, or I mean, is there anything in particular you want to look at? Or just more of whatever?
Could you do another negative one?
Sure. Okay. One that's going to have a both, or that's going to have just a negative?
Just a negative.
Okay, let's see here. What I'm trying to do is make sure I do one that I didn't already do. Let me look back here for a minute. Let's see. Yeah, okay, I don't think I did this one. So find the first 5 terms of a geometric sequence with the following properties. The first term is 2, so a sub 1 is 2. the third term is 50. So we've got a sub 2, a sub 3 is 50, and it said at the beginning to find the first 5 terms. And it also tells us that r is less than 0, okay? So we're supposed to find the first 5 terms. We're given the first term, we're given the third term, we're told that the common ratio is negative because it says less than 0. All right, is this kind of one of the ones like what you'd want?
Yeah.
Okay, so again, a sub n equals a sub 1 times r to the n minus 1 power. A sub 3 equals a sub 1 times r to the 3 minus 1 power. A sub 3 equals 2r squared. But a sub 3 also equals 50. So 2r squared equals 50. Divide both sides by 2, r squared equals 25. Oops. If we take the square root of both sides, we get plus or minus the square root of 25, which would be plus or minus 5. But since r is negative or less than 0, same thing, r has to equal negative 5. So 2 times negative 5 is negative 10. Negative 10 times negative 5 is positive 50. Positive 50 times negative 5 is negative 250. Negative 250 times negative 5 would be positive 1,250. So there we've got, what have we got? Oh, we've got the first 5 terms. You okay with that?
Yep. Thank you.
You bet. Let's see here. That's positive. Somebody else? Anything? All righty. Well, I'll be back at 1:15 this afternoon with an office hour. And again, so make note of your assignment. You actually have 2 sections tonight. You have 14.3, and then you have the chapter review as well, okay? If you hold off and don't do the chapter review till tomorrow night, you won't get any feedback from me because on Wednesday, there's no class meeting. So the idea is that tonight you're gonna do 14.3 and the review, not really a chapter, but it's review of all the different sections we've looked at. And tomorrow we'll answer questions from that, look at the chapter review stuff for a test on Wednesday. Okay, so let's stop the recording.